Hello everyone, welcome to another math online lesson. Our lesson for today is quadratic inequalities. Now, how do we solve quadratic inequalities? To solve quadratic inequalities, we have the same process as solving in the quadratic equations. Okay, first, we need to factor our trinomial. So how do we factor this one? First, find the factors of your last term. So you have 12 times 1, 6 times 2, 3 times 4. Now, among these factors, only 3 and 4 could come up with a 7. So we use the factors 3 and 4. And since 12 is positive and our middle term is also positive, so we use both positive factors of 12. So let's go ahead and plot this one. So I have x plus 4, x plus 3 greater than 0. Then next, proceed to the zero product property. So I have x plus 4 greater than 0, and also I have x plus 3 greater than 0. Now to solve for x, simply use the additive inverse or just transpose 4 to the other side of the inequality. So we have x greater than negative 4. Same goes here, transpose that one here. So you have x greater than negative 3. Now the next step is to plot this one in the number line. Because if you can still remember, when you were in grade 7, we learned that when it comes to inequality, we have multiple possible answers or solutions to the given equation, or even infinite number of solutions. So in order for us to know what are the possible solutions to our inequality statement, we need to plot our answer in the number line. So we have our positive integers here, and we have the negative on the left side. Now, since the inequality symbol being used is greater than, so we use the open circle in plotting it in the number line. It means that 3 is not a possible solution to our inequality statement, so was negative 4. Now, let's try to prove if negative 4 and negative 3 is not part of the solution. If x is negative 4, so I have negative 4 plus 4, that's 0. Negative 4 plus 3 is negative 1. 0 times negative 1 is 0, which is not greater than 0. So it makes the statement false. Therefore, negative 4 is not part of the solution. Now how about if x is negative 3? If x is negative 3, negative 3 plus 4 is 1. Negative 3 plus 3 is 0. 1 times 0 is 0. Still, it makes the statement false. Now, as you notice in our number line, it is being divided into 3 parts. Now, in these 3 parts on our number line lies the possible solutions to our inequality statement. So if negative 3 is not a solution, let's try negative 2. Negative 2 and negative 2. So if x is negative 2, negative 2 plus 4 is positive 2. Negative 2 plus 3 is positive 1. 2 times 1 is 2, greater than 0. It makes our statement true. Therefore, from negative 2 going to the positive infinity are solutions to our given inequality. Now, if negative 4 is not part of the solution, let's try negative 5. So if x is negative 5, negative 5 plus 4 is negative 1, negative 5 plus 3 is negative 2, negative 1 times negative 2 is positive 2, which makes a statement true. Meaning, from negative 5 going to the negative infinity are solutions to our inequality statement, leaving us the values in between negative 3 and negative 4, not solutions. Okay? So to write our final statement or answer for the solutions of our inequality statement, we can write based on the result in our number line, we can write as x should be greater than negative 3, that's greater than negative 3 going to the positive infinity, any values of x greater than negative 3, and any values of x less than negative 4. So when you read this one, you need to start from x, and your basis would be your number line. Again, from x, values of x greater than negative 3 are solutions, and values of x less than negative 4 are solutions. So you need to read that one both ways. This one is less than on x in terms of x. This one is greater than in terms of x. Let's have another example. Let's do it on the next page. Okay. So I have here x squared minus 36 greater than or equal to 0. Again, we can solve this one using the equation technique on the extracting the root. So you need to use the additive inverse to separate the variable and the constant, or just use the transpose method. So that is x squared greater than equal to your negative 36 becomes positive 36 on this side. Then extract the root on both sides. This will cancel out the exponent and the radical sign, leaving you with x. Bring down the greater than equal to symbol. The square root of 36 is plus and minus 6. So this leaves us as values of x greater than positive 6 are solutions, and values of x greater than or equal to negative 6 are solutions. Now, for us to be able to check if we got the correct answer, we need to plot that one in our number line. So you have your 0, your positive, 2, 3, 4, 5, 6, 7. So you have 1, 2, next you have your negatives. So you have negative 1, negative 4, negative 6, negative 7, negative 8. Then, let's try to plot our result. Now, since we use the greater than equal to symbol, meaning when we plot that one in our number line, we use the closed circle. So this means that 6 is part of the solution. So as negative 6. Now again, if you notice here, our number line is being divided into 3 parts. So let's try to find out the other values that can solve or a possible solutions to our inequality. So let's try to prove first if 6 is indeed a solution to our inequality statement. So I rewrite this one here, x squared minus 36 greater than or equal to 0. If x is equal to positive 6, so you have 6 squared, which is equal to 6 times 6, 36, minus 36 is equal to 0, which makes our statement true because we have the equal sign here. That's why we use the closed circle. If x is negative 6, will give us the same result because negative 6 squared, or negative 6 times negative 6, is equal to positive 36, minus 36 will give us 0. Now let's try to find out what are the other possible solutions to our inequality. So let's try positive 7 first. Okay, if x is 7, you have 7 times 7, that's 49. 49 minus 36 will give you a positive result, meaning it's greater than 0. So therefore, from positive 6 going to the positive infinity are solutions to our inequality. Let's try to check for positive 5. Again, you need to double check your work, checking the left and the right of your result. So if x is 5, so you have 5 squared, 25, so 5 squared is 25, minus 36, you have a negative result. It's not greater than 0, so it makes our statement false. So meaning, from 5 going here are not possible solutions. So as negative 5 here. If your x is negative 5, you could still come up with the same result, meaning this area here are not possible answers or not solutions. Leaving us with this side. Let's try to check if this side are solutions. So if x is negative 7, so you have negative 7 squared, or negative 7 times negative 7 is 49, positive 49, you have a positive result, which is greater than 0. Meaning, from negative 6 going to the negative infinity are solutions to our inequality statement. Therefore, we can write our final solutions as, again, base your final statement on the result as on the number line. Okay, so the values of x greater than 6 are solutions based on this one, and values of x less than 6. It's greater than equal to, less than equal to negative 6. Again, because we are using the greater than equal to symbol. So to read this one, you need to read this one both ways. So you have values of x greater than or equal to 6 are solutions. Values of x, sorry, this is less than. So any values of x less than or equal to 6 are solutions. So I hope you learned something today on quadratic inequalities. See you in my next online lesson.